In lesson 8.3, we are going to talk about solving right triangles, and solving our triangles simply means that we know all of the side lengths and all of the angle measures. And we are going to continue to work with our trig ratios. I'll remind you that our trig ratios can only be used with our right triangles. So at the top you can see I have a 30, 60, 90 triangle, and I'm wondering about the sine of 30 degrees. Now we could punch that in our calculator, but we also know the ratios for our side lengths for a 30, 60, 90 triangle look as so. And the sine of 30 degrees, here's my angle. We are doing opposite over hypotenuse. My opposite side over my hypotenuse side, we would get 1/2. And even if we had different numbers, let's say we had 6, 12, 6, 3, they have to follow those ratios. So if our side lengths were different, the sine of 30 degrees simplified will still give us the 1/2 fraction. 6 over 12 would reduce to 1/2. Well, today we're going to look at some examples where we might not know our angle. Instead, we know the ratio. And so we're going to look at what happens if I know the ratio. How can I determine my angle? Well, in this case, this would have to be 30 degrees. The only angle that has a sine ratio of 1 to 2 is a 30-degree angle. That's true. All of our angles that we talk about, the ratios are specific to that angle. Now, we actually are going to talk about using the inverse trigonometric functions. So looking down below, it says, if given any two sides of a right triangle, trig ratios can be used to find the two acute angle measures. Using the inverse functions will allow you to find the angle measure. The inverse functions look like this. They look similar, sine, cosine, tangent, but they have the little -1 by them. That doesn't really mean to the -1 power. It simply means that's the inverse of the function. And you have those buttons on your calculator as well. If you look right above sine, cosine, tangent, you have sine to the -1, cosine to the -1, and tangent to the -1. Those are the inverse functions. So in the chart, what they are trying to say is that your sine of angle A equals x, then the inverse of x would equal the measure of angle A. So the inverse function is really, if I had the inverse sine of the sine of angle A, these are opposite operations. They kind of undo each other. We're simply left with the angle. And that's what they're telling us kind of in this chart here. So if you look down below, they're asking us to use our calculator to find each angle measure to the nearest degree. Well, the sine of angle A equals 2/3. We want to know which angle has a ratio opposite to hypotenuse of 2 to 3. If I'm solving this algebraically, and I take the inverse sine of the sine of angle A, what I do on one side, I have to do on the other. The inverse sine kind of cancels out the sine, and we're simply left with that angle A would be the inverse sine of 2/3. Now, we don't always write out all of those steps, but I wanted to show you that. On my calculator then, to use my inverse function, I'm going to hit second sine so that I have the inverse. And then I'm just going to hit 2 divided by 3. And again, it's a good habit to get into closing your parentheses. Typically, they're going to ask us to round these to the nearest degree, and so this would be approximately 42 degrees. So here angle A approximately 42 degrees. And really, we would calculate all of those as so. The cosine of angle A equal to 1/2. Well, if I wasn't sure what angle that was, I would think about taking the inverse cosine of both sides. So my angle A is the inverse cosine of 1/2. I'm going to go ahead and calculate that. Inverse cosine, I'm going to hit second cosine, 1 divided by 2. And I can see that is a 60-degree angle. That makes sense because, as you recall, for our 30, 60, 90 triangle, the cosine would be adjacent over hypotenuse, 1/2 for my 60-degree angle. And then finally, tangent of angle A equals 1. Well, that tells me that angle A would be the inverse tangent of 1. A 45-degree angle. I guess over here, this is exactly. Sometimes they are written a little bit differently. Down here, 4, 5, and 6, they're just asking us to calculate them, and they gave the ratio as a decimal, probably rounded to the nearest hundredth, and so I'm going to calculate them the same way. I'm simply just going to type in my decimal. Again, we're going to round these to the nearest degree, and so this would be approximately 30 degrees. All right, so let's take a look at setting up and doing some solving. In example B, they are asking me to find the measure of x. Now again, we need to use or have a right triangle, and I have a 6, 8, 10 Pythagorean triple. I'm wanting to know this angle measure. In this instance, I have all 3 side lengths, and so really I could make use of any of the trig ratios. A little reminder that our helpful saying was SOHCAHTOA. From angle x, I have the opposite side, I have the adjacent side, and I also have the hypotenuse, and so I could pick any of the functions to use. Let's go ahead and take a look at using the sine function, or the sine ratio. This here, we don't know our angle, so when I set this up, my sine of angle x is going to be equal to opposite over hypotenuse, as so. And we simply need to just find our angle measure. So I know that if I take the inverse sine, I'm left with x, but what I do on one side, I have to do on the other. And so x is equal to the inverse sine of 6 over 10. Rounding to the nearest degree, we're going to find out that angle x is approximately 37 degrees. Now again, I could have used a different trig function, but that means my fraction here, my ratio would have set up a little differently. Had I used the cosine, I would need the adjacent over hypotenuse. And well, my inverse cosine of 8/10 set up differently, but you'll see that we still get the same angle measure. Okay, let's look at number 2. Number 2, they're asking us to find the measure of angle y. I like to circle them just to give me my visual. Here, I don't have all 3 sides of my triangle. From angle y, I know 100 is going to be the opposite side. and 41 is going to be the adjacent side. I don't know my hypotenuse. So I could calculate my hypotenuse, but that would just be some extra work. Let's go ahead and think opposite and adjacent. That's going to tell me to use T for tangent. So my tangent of angle Y is going to be equal to opposite over adjacent. Again, our order is important. So we know that the angle Y is going to be the inverse tangent of 100 over 41. To the nearest degree, our angle Y is going to be about 68 degrees. Could I find my other angle measure? Sure. And I could use the trig functions, but if we know this is 68 degrees, we could then subtract from 180 degrees, right? We would know this would be about 22. Taking a look at our last one, it says when a triangle is solved, all three side lengths and all three angle measures are known. So basically, we have all of our measurements. In example C, they're wanting us to solve our triangle, rounding the lengths, the side lengths to the nearest hundredth, and the angle measures to the nearest degree. Looks like we are going to need to find side ST, and we're going to need to find angle T and angle R. There's some different approaches you could take here. When I see finding side ST, I don't know any angle measures currently. The first thing I see is that I could use the Pythagorean theorem. And so I don't have to use my trig ratios to solve for every part of that. I could say x squared plus 5 squared equals 5.7 squared. And I could go ahead and I could solve that for x. Now, if you solve that through, you're going to find out that x comes out to about 2.74 to the nearest hundredth. So my side ST, let's say, is about 2.74. If I wanted to find one of my angle measures, though, I am going to have to use a trig ratio. And I'm just going to go ahead and think about solving for angle T. Now, I could pick any of the three sides, but because these two sides are exact, and this is an approximation, I'm going to prefer to use my opposite side and my hypotenuse when solving. For my angle T, then, I know opposite and hypotenuse would be the sine function. The sine of angle T would be 5 over 5.7. In other words, then angle T would be the inverse of 5 over 5.7. So to the nearest degree, it looks like we're going to say that angle T is about 61 degrees. If I wanted to calculate angle R, I could certainly use my trig ratio. In fact, angle R would be, I could use adjacent and hypotenuse. But if I already know that this is 61 degrees, I can really take 180 minus 90 minus 61 to find out that angle R must be about 29 degrees. So now I have solved my triangle. I have my three side length measures, and I have my three angle measures. If I wanted to go back again in solving side ST with the trig ratios, I certainly could. I'd have to use one of my angle measures, and then I could solve for that missing side that way as well. If you have further questions on this, please step in and see me.